Hello everyone, this is Joslin and this is a short presentation for my final project for programming for geospatial analysis at Oregon State University. My final project will look at the complexity of landscapes for suppression of fires by on-the-ground resources. For this project, I'm going to base that on slope, aspect, fuel model, canopy cover, and canopy fuel base height. The goals for this project are to produce a file that ranks the complexity of a landscape in terms of how hard it would be for suppression forces to suppress a fire, and a layer file to display it easily. This project is specific to ground resources, so hand crews, hotshot crews, repellers, jumpers, engines, and heavy equipment. Keep in mind that the accessibility of vehicles and heavy equipment is different than people on foot. This will not apply to air resources actively suppressing the fire, though airplanes and helicopters are used to transport people. The input for this program is a landscape that can be located at the Landfire website. Anyone can download this and it's free. It is important to use the 2022 version and download the slope, aspect, fuel model, canopy cover, and canopy fuel base height bands. Here are the instructions to download a landscape from Landfire. Once it shows up in your inbox, unzip it and save it in a folder named Landfire. To start my code, I have general information about the program, and I also import ArcPy so I can use specific functions found in ArcPro, and I import systems so that I can access system-specific parameters and functions. Then I also import the spatial analysis tools. Finally, I ask the user for some input. I ask them for the folder where they are storing their Landfire data. Next, I start a try block where I will be catching errors throughout the whole program, and I assign the workspace. Then I start with a series of reclassifications, starting with slope, where you can see that any slope that is between 0 and 20% will have a 0 value, and any slope greater than 20% will have a value of 1. And then moving into aspect, it's reclassified, so basically any aspect that is south or west will have a value of 1, and all other aspects will have a value of 0. Here I am reclassifying canopy base height to anything below 15 feet, receiving a 1, and anything above 15 feet, receiving a 0. And also, I'm reclassifying canopy cover so that anything less than 25% cover receives a 0, and anything over 25% cover receives a 1. Last, I reclassified fuel model. This is based on the rate of spread of each fuel model. You can see that the number of fuel models is greater than 13. The fuel models in the 90s are those areas that are non-burnable. Barren land, glaciers, rocks are examples. Then I used the spatial analysis math to add the rasters together. This had to be done 2 at a time, so I added slope and aspect together and then added the output of that to canopy base height and so on. Once I had completed all the additions and was left with one raster file, I noticed I had an output range of 0 to 5 instead of 1 to 5, so I did one final reclassify to combine 0 and 1 into one class. Then I used ArcPy management add field to add a text field to the attribute table called complexity. Here I am using an update cursor to add inputs to the complexity column in the attributes table based on the value in the value column. I used a for else loop to assign very low to values of 0 or 1, low to values of 2, moderate to values of 3, high to values of 4, and very high to all others. Then the cursor updates the rows. Here is the except block that works with the try block that I started at the beginning to catch errors. If an exception is found, then the program will tell the user that it caught an error and to check your input. The exception will be displayed, then the system will exit the program. I found the most common issue was not naming the folder where the data is located, Landfire, or not putting the location of the folder correctly. If the program runs successfully, Then the user is told to have a great day. During the process of creating this program, my ability to debug evolved. I started with using suggestions in PyCharm and simply running code and then searching for where it broke. Then I learned how to add breaks so that I could run sections of code. That way I could more easily narrow down where the issues were located. Then I learned how to add a try except block and have the program tell me where the error was. That seemed to work the best. After running this code, the output of the program is a single band raster file with values of very low to very high complexity. The final step was to create a layer file in ArcPro to assign the correct colors to the output. This layer file is included in the folder with the program's code. Okay, here's a demonstration of my code running. Go ahead and click Run here. And the first thing that happens is that the code is going to ask for user input. You can see here, hello, please provide me with the location of your 2022 Landfire folder in this format. Input location here. And if I don't follow that format and I put in something that's really, really wrong and press enter, then I have a try block and you can see that it failed to execute, and it says caught error, please check your input, failed to execute, parameters are not valid. So oops, so I will try running that again, and this time I'm going to copy paste my location so I know that I get it right, and I'm going to follow the format and then press enter. And as this processes through, you can see my try block starts at the beginning and ends at the very end. And it looks like it's finished running. Here's the slope being reclassified, the aspect being reclassified, canopy base height being reclassified, canopy cover being reclassified, and then also the fuel models being reclassified. And then they are combined together into one using the add rasters, and then reclassified one more time to get the ranking. And then in order to get the complexities, instead of just values, I added a field and then added information to those fields depending on the value in the value field. And then there's the end of the exception for catching errors. And then as you can see at the bottom here, if you didn't have any errors and everything ran successfully, you get the message, go play with your data and have a great rest of your day. Okay, here we are in ArcPro, and our run was successful. Just go into Landfire and click on refresh, and you can see here the reclass has popped up. Drag that in. Take a second for it to come up. And there we can see it. Okay, so we have our TIFF file, and the last thing we need to do is apply a layer file to it so the colors look right. If you right click on your TIFF file in the contents pane, then you can click on symbology and your symbology window will open. If you click on the 3-bar menu in the top right here, you can click on import from layer file. Unfortunately, this video service does not let me film anything that's in File Explorer. So right now my folder has, my file is open and I just need to navigate to where the layer file is located and click on it and click OK, and that is in the Landfire folder that I included with my final project. And now you can see that it has applied the layer file to the values. Thanks for watching.